Thank you so much. A little bit of technical difficulties. I'm definitely getting a Mac after this. Those ones always work whenever you connect them to the screens. But yeah, let's get started. Before start, let me ask two questions. Who here has attended talks on API security? Raise your hand. Yeah, a couple of you already, right? Who here has attended of talks about vulnerable dependencies, software bill of material, those kind of topics lately? Yeah, there is a third type of vulnerability that I'm gonna talk today, which is command injection, one of the oldest ones, but I have seen that it's not often mentioned very much. So a little bit about myself. My name is Lenin Alevski. I'm currently working as a security engineer for Google in California. I'm also an open source contributor. I love software. I love to contribute to new projects. If you have something interesting going on, please reach out to me. I would love to collaborate. I have been working in small companies, big companies, everything in between. So I have seen a lot of things. And I really love cybersecurity, right? I really love teach and learn from others, listen to their projects, what they are doing, stuff like that. So this is the agenda for today. I'm going to talk a little bit about the different types of software integrations, what are the most common pitfalls associated with that. We're going to talk a little bit of a couple of case studies, vulnerabilities that happens in the past. We're going to deep dive into one of the security research that I did last year. And finally, we are going to do a quick read-through of a couple of low-hanging fruits, trying to detect and mitigate these kind of issues. The usual disclaimer, these are just my opinion. This doesn't represent the opinions of my past employees, current or former employees. And with that, let's get started. Software integrations. Probably here we all agree. It doesn't matter if you are learning to write your first line of code or you are an experienced developer, that use a single program, like program that doesn't connect to other programs, is not very useful, right? In order for a program to solve a task, to solve a problem, it has to somehow connect with other platforms. At a very high category or a very high level, there is three types of categories. The first one, which be libraries and code dependencies. That means we are importing other people's source code, other people's functions into our program. There is a second type, which is external services or being integrated to external services. That means our little program is calling other people's code over a channel, over the network. And then the third type is exec commands, which means not just importing a single function, a single line of code, but calling entire programs into our context, right? Executing entire programs. There is a couple of issues that I have seen in the past, pitfalls associated with each one of those. For example, for the first type, you have all your traditional vulnerable dependencies. You have dependency confusion, supply chain attacks, type of squatting, misconfiguration, stuff like that. Here we're talking about SolarWinds, about the Log4j incidents. Here you have your adversaries trying to take over GitHub repositories in hope of pushing malicious code that then is going to get imported into other people's projects. The second type of vulnerability, when it comes to external services, probably here your concern is more about data validation and data sanitizations. You want to make sure you have integrity, you have authenticity. You want to make sure you are talking to where you are supposed to talk to, right? Your concern here is the data security in transit, data privacy. And here they're having a couple of issues in the past. The most common one is whenever people push data into publicly exposed S3 buckets. Like they do that type of integration and then don't make sure whatever repository they are pushing the data is secure. We have the Capital One data breach. We have a couple of outages caused by AWS in the past that are affecting a lot of companies. And this is as simple as if you are building a website, you have to protect from scrapers, right? And then the third type of vulnerability, the exec commands or the system calls, these ones are more associated with traditional command injections, privilege escalations, vulnerabilities around the file systems, and enterprise communication vulnerabilities. I'm pretty sure all of you know Equifax. It was a massive data breach that happens in a couple years ago. It affects over 800 million different individuals and 80 million companies around the world. And most recently, we have the Microsoft Exchange server-side request forgetting vulnerability that fundamentally it was a common injection vulnerability. So for the rest of the presentation, we're going to deep dive into this third category. And lucky for us, I have very detailed research that I did last year that I'm gonna tell you all about in a couple minutes. But before telling you that, let me tell you about the motivations for this, right? And hopefully I also inspire others to do more security research on open source project, to go and look into the code for vulnerabilities and report them, and together we make open source software more secure. So as probably some of you already know, or some of you are, I'm a very big fan of home labs, right? I think home labs are a great environment for you to test and learn cybersecurity in a secure way. You can screw your home lab, doesn't matter. You can rebuild it again. My current setup looks it contains a little bit of everything. It has virtual machines, it has bare metal, it has cloud machines, it has everything. And I start having a problem, right? Which is, how can I manage all those different systems? So when I was learning the hobby years ago, I discovered this great tool called Ansible. But for people that doesn't know, I'm gonna give you a quick intro into Ansible. Ansible is a little program, a little solution that will allow you to manage different platforms, different operating system in an automated way. And it's pretty cool because it's platform agnostic, operating system agnostic, device agnostic. So usually you have a centralized machine, a central computer that you use to connect to all the other ones and execute tasks. These tasks are often called playbooks, and a single task will run an operation on that remote machine. For example, here we have a task about updating the system. And for a while, it was a great solution for me, right? I have my machine, I SSH, I run the commands, and everybody's happy. But sometimes I didn't have my machine, or sometimes I didn't feel like using the CLI for that. So I thought there should be a better way, right? So I love open source, so I will start looking into which projects are there. And I found this really cool project called Semaphore UI, which Semaphore UI sits on top of Ansible or other automation tools, system management tools. And it offers you a great UI with a lot of capabilities and features, access control, stuff like that. And I used it, and it was amazing, right? On paper, it looks great. So we have Ansible, which is the tool that I use to manage my other system. Then on top of that, I have Semaphore UI. So now I'm going to use the Semaphore UI to manage my machines. It's great because it can reuse all of my existing playbooks that I pull from a repository. And I can expose Semaphore. If Semaphore is running on my home lab, I can just expose it into the internet in a secure way, or I can run it on the cloud, right, and give it access to my home lab. I used it for a while. However, at some point, my hacker sense start thinking like, how does this thing works, right? What's the integration there? How Ansible interacts with Semaphore UI, and how Semaphore UI interacts with Ansible. So I download the project, I start looking at the source code, and I found this little line of code that, if I'm being honest, scared me a little bit, because I just saw that they are just literally calling the Ansible playbook binary, right? They are doing this using a native package from the Go programming language. And yeah, when I saw that, I say like, we have a problem here, right? So yeah, it is what it is. But then I start looking more into the code, and it's not like really, really bad. They are kind of hard coding the binary name. And in Go, Go makes a good separation between the binary, the arguments, the parameters. So if you want to trick the programming language into sending a parameter as a binary, they will stop you, right? However, I still don't feel comfortable running this in my home lab after I found that, right? So as a security engineer, I start thinking ways on how this can impact what's my risk, right, in my home lab. And I start investigating Ansible from a security perspective. So introducing Ansible security, the first thing that I did was, for those of you who don't know, I highly recommend for you to bookmark this website. GTFO is a repository of binaries that will have basically like a library of different ways in which you can abuse these existing binaries to achieve privilege escalation, command execution, and so on. So you can just literally go to that website, type every binary, any binary that you want, and it's gonna give you some ideas, right? And if you are in the Windows environment, there is also like a sister website that is focused, but for Windows binaries. So armed with this knowledge, I start, making like malicious playbooks. So these malicious playbooks are gonna be executed by the Ansible playbook binary, and then I can run those Ansible playbooks binary from the Semaphore UI platform. For example, this playbook will give you an interactive shell on the system that is running this Ansible command. There is many examples. If you want to achieve server-side request forgery, there is a playbook for that. Or if you want to read sensitive files on the system, right? You can also do that via the Ansible playbook binary. And traditionally here you have your reverse shell, right? That is what we use into our proof of concepts. So with that, let's go back to our architecture diagram. We have a security issue here, but Semaphore UI gives us some security features, some security capabilities. One of that is access control and separation between different levels of users. With the knowledge that we have now, we understand that if a regular user is able to execute a malicious playbook, that's game over. However, we can configure the platform, we can configure GitHub in a way that only administrators can upload playbooks. And once those playbooks are authorized and curated and analyzed, regular users are just gonna run this, right? And this looks a little bit better. But if we go back to the source code and we look at the code, we still see that there is two more parameters, right? And those parameters are arguments that you are going to pass to the Ansible playbook and environment variables. So it is possible that the attacker abuse these two pieces of data that they control. Let's find out. So in the Semaphore UI, there is this screen that directly correlates to those arguments that I just mentioned. And these arguments are the extra variables arguments. So then what we're going to do is we go and read Ansible playbook documentation, and you will find that these extra variables basically allow you to define. It's kind of like a cool way to customize the execution of your playbooks. You can pass data in a key value format, or you can pass it in a JSON format, reference a file, upload some YAML. It's very flexible. So what I found is that, and this is not documented, or the last time that I checked, it's not documented in the Ansible playbook, but these arguments allow you to pass something that is called lookup functions. These lookup functions are very similar to what is going to be traditionally called a server-side template injection, in which Ansible will receive a couple of arguments, a command, and some values, and it's going to process, it's going to do some evaluation, and then the result is going to get passed to Ansible playbook, right? So with that said, we can update our malicious extra variables, and we can now do things like reading the Semaphore UI configuration or exfiltrating some environment variables, right? And all this can be done using a regular user account. So this doesn't have to be the admin of the Semaphore UI platform. When you exfiltrate the configuration, this is kind of critical or scary because this configuration may contain some cookies, some encryption keys, some crypto materials, stuff like that. But not only that, you can also do what I showed you before, the different type of malicious playbooks, but using the extra variables. For example, here we have the server-side request forgery. We also have the out-of-bind exploitation. But there is a caveat for that. In order for this extra variable to get executed or get interpreted, it means first it must exist in the playbook that you are targeting. Lucky for us, again, like reading the documentation, there is a thing called global variables. So these global variables will be, they will exist always in the Ansible ecosystem. So you can just send your malicious payload, your malicious variable, and reference one of these global variables, and it will run. So I have a quick demo here, which is a reverse shell. So, and as I was saying, on the left side, we have our traditional netcat listener. On the right side, we have a regular user of the semaphore UI. It input a couple of malicious variables, and then it's going to run a playbook that is authorized, which is very simple. Is the update system configuration, right? Update system packages. So once it runs, it's going to do a reverse connection back to our netcat listener. And we are going to take control over the machine executing that update, right? Not the Ansible semaphore, but this potentially can give you control of the entire infrastructure. So what really happened here, right? What I just explained. So we have the Ansible playbook. The Ansible playbook has these advanced capabilities called the extra variables that by design allow some type of code execution. And as I was mentioning, this was not documented in the Ansible website, as far as I remember. And these developers, they were trusting the Go native exec command function, trusting the separation or the logic that is there that it's going to prevent arguments to be treated as commands. But that effort is defeated because the command itself, the binary itself, allows you some advanced capabilities. So now let's think about red teaming, right? How can we escalate this in our reviews? So take a minute to analyze this. Imagine you are kind of looking for vulnerabilities in this piece of code. The first thing that can go wrong is if you are able to control the first argument, that's command execution out of the box, right? If you are able to control either the parameters or some of the environment variables, you may be able to influence the way the program works, the program execute. If you are able to control the folder, that may lead to some unintended behavior, unintended access in the system. And if you are able to, this is one of my favorite ones, if you are able to pass unsanitized data or data that is coming directly from the user, directly into the standard input of the binaries, interesting things happen there, like buffer overflows and stuff like that. And finally, most of the time, these external programs, external binaries are going to generate some type of output. And this output may contain sensitive data, like credentials, tokens, stuff like that. So then you can use for lateral movement of privilege escalation. The cool thing is that virtually these kind of native functions exist in pretty much every programming language. So you can just go read them, see which parameters they use. And besides traditional fuzzing or dynamic testing, I always recommend go and read the documentation of the program being imported or the program being run, because sometimes it has very interesting advanced capabilities, right? Like in this case, Ansible playbook, it has command execution, right? So now let's talk about the blue team side of things, right? How do we prevent for this? I always say, like, whenever you are trying to make this decision of how to integrate your program with other platforms, other programs, literally, like, this has to be your last option, your last resource, right? I have seen a couple of reasons people do that. The first one is because whatever program they are trying to call doesn't have a native API, doesn't have an SDK, or is too old that is legacy code that there is no other way to integrate. So if you have an option, if you have like an API or a different way of integration, please first prefer that. If you are unlucky, then the next thing that you have to do is going back to the roots of security engineering, right? Do a security review, do a threat modeling, try to figure it out how this integration will impact the whole security of the platform. Then always follow the least privilege principle, throw out there some static code analysis tools, try to find where in your source code you are calling these programs. Very important, do input validation and sanitization. And it's always good to do some security training and awareness for the developers, right? But the most important thing here, the takeaway, what I want you to take home is that this is a continuous process. You have to do this for every integration that your platform do, and you have to iterate and hopefully reduce the vulnerabilities from the design phase. So with that, today we talk about the different ways of integration, the common pitfalls. I mentioned a couple of cases. We did a deep dive into the CVE that I report last year to the Semaphore UI people. And then we discussed a couple of low-hanging fruit on how to attack and how to defend for this type of vulnerabilities. I don't know if we have questions if we have time for questions, but if not, thank you so much for attending my talk, and I'm gonna be around. Please reach out to me if you have any additional questions.